So the good thing about short talks is that when they're bad, they're short. And when they're good, they're still good. So quick poll, has everyone here ever seen a lightning talk session? Like who doesn't know what it is? Okay, so the principle is that we have a very quick series of very short talks of 5 minutes. There are no questions. It's like a gong show. After 5 minutes, you're done. You must go. You drop the mic, okay? And so this is the lineup. We've got 12 talks in 1 hour. And the first person is going to be Miroslav on PyCon.de. There you go.
Bonjour tout le monde. Hi everyone. Who did come to Karlsruhe to the German PyCon 3 weeks ago? 1, 2. Okay, so you are not lucky all the rest because it was for the last time for the following few years that German PyCon was so near to Paris. Here is Karlsruhe. This is 2.5 hours of train. Next year, on the 9th to 11th of October 2019, we are going to move to Berlin. So, if you take a train to Frankfurt and then change for another train to Berlin, 8 hours. If you take a night train from Paris in direction of Moscow, like this, 12 hours, but overnight. But you can still fly. So, we are going to be in Berlin, beginning of October 2019. It will be in the, which area? In the Cosmos venue. So we are looking forward to you. The website will be online in a few days, weeks, or months. Thank you very much. And all sessions are going to be in English.
So, hello everyone. My name is Sunniva Indrehus. I'm a second year PhD student, and I work with Fortran. So I have chosen the very provocative title, Fortran Rocks, in a Python conference. And the reason why I work with Fortran is because I work in the physical domain. So this is an illustration of the system I'm working with, where we try to solve the plasmonic interaction in metallic particles on glass. A bit technical, but just to show you an illustration of our system. And this is the reason, these equations, this is what I want to solve. So this is the reason why I don't use Python. Because you need the right tool to the right job. And we have a lot of heavy numerics, so it's much better for us to use Fortran. But I do not want to become like my master supervisor. When I took my master, he still uses Fortran 77, which is ridiculous. So I tried to learn Python and use notebooks. So we have created a Python interface for our Fortran code to users. Yeah, and I did this with pictures instead of the notebook. I don't know. I just thought it would be more practical, but maybe it wasn't. Yeah, and this is just to show you an example. So what we actually do is that we have an input file for our Fortran code. So we use the Python first, and then we say we want this and this input parameters. We give these and these values. Then we generate this input file for our Fortran code. We run the Fortran code. And afterwards, Python reads the output. Simple. This is just a classical plot from the plasmonic community where you see the polarizability has a real and imaginary part. So, result. Thank you.
Okay. Yeah, my name is Marco. I'm a data scientist and I'm a brewer. And later you can tell me which one should be my job. If you don't like beer, you can still enjoy the presentation because it's about over-engineering. If you do like beer, my suggestion is that you learn a little bit about brewing, ingredients, styles, beer cultures, and so on. Rather than chugging one pint after the other, you learn more about what you're drinking, you will enjoy it more. So let me walk you through brewing very quickly. In terms of ingredients, these are the 4 core ingredients. So water, whenever you see your beer is 5% alcohol, the other 95% is mostly water. Then malt, barley malt, wheat malt, oat, rye, and whatnot. And that's going to form the backbone of your beer. Hops for bittering and for aroma, and finally yeast to make the magic and actually make the beer at the end of the day. And that's the brewing process. It looks complicated the first time you look into it, but really something you can do in your kitchen. So mashing would be putting water and grains together, doing a bit of a porridge at some controlled temperature, then you bring it to boil, you add the hops for bittering. Finally, you cool it down to room temperature, and then you pitch the yeast for the fermentation. You let it be for a few days or for many days, and then you have beer. In terms of putting a recipe together, is an example of how a beer recipe looks like, a bit complicated, a lot of ingredients, a lot of steps. But in principle, if you're a brewer and they give you this one, you should be able to replicate the results. And the results in this case are quite good. Now, I've been doing it for a while, so I'm quite confident in kind of coming up with my own recipes, but I also like to go online and get some inspiration. So there are many forums and websites where people share their knowledge, share recipes. So the home brewing community is pretty much open source from this point of view. So people who share the recipes online are nice, and people who share the recipes in a machine-readable format are very, very nice. So why should I bother reading a recipe when I can download it and analyze it? So this is where things get out of control. I wrote a script using the request library. I got a bunch of recipes, URLs. I download some stuff. I have a bunch of recipes in XML. And then using a wrapper, PyParis, I can translate back into a text format for me to read. I ran it for a while. Now I have, I think, 80,000 beer recipes. So I'm not going to read them all. So I had one problem. I use Python. Now I have two problems. Now, if you don't talk about neural networks, people don't take you seriously nowadays. So this is a neural network. Input, output, hidden layers, you know everything about it. Now, my recipe doesn't fit the standard neural network format because it's kind of a sequence. So I have to use sequential neural networks. And because I do natural language processing, when you have a hammer, everything must be a nail. So I'm using essentially sequential neural network, and in particular, things that work well in natural language processing. So, using Python, of course, you have a lot of support for neural networks. In particular, here I'm using Keras to build my NLP kind of analysis, and now I have an AI that is able to generate beer recipes. So, ethics in AI is a bit of a hot topic nowadays. So before jumping into doing AI, we should kind of ask a couple of questions. First, are we taking the fun out of it? Yeah. Secondly, is the beer any good? Not even close. So since you're all here, I just also want to take the opportunity to invite you to London. We have a nice PyData conference. We do have beer. We have soft drinks as well, and we talk a lot about over-engineering, data engineering, neural networks, and all the friends. Thank you very much.
Hi everyone, I am Mojde. I am part of the data lab team in Saint-Gobain Research. So pretty much I think most of you guys use TSNE as a visualization tools when you have an embedding system. So today I would like to introduce UMAP, Uniform Manifold Approximation and Projection Toolbox, that I heard about it listening to the SciPy talk this year. And it's a very cool tool, and it's interesting to know about it. So UMAP is, besides being, you can use it as a visualization tool, is also nonlinear dimension reduction. That, and also you can be used as an unsupervised and supervised learning tool to transform your data. When TSNE, you don't have that option. And it's fast, it can handle large data set and high dimensional data set as well. And it also scales well in embedding dimension. So this is the repo of the I cannot pronounce his name correctly, sorry, but the repo is there, and you can install it with Conda Forge. So let's look. I use the digit dataset quickly, and just comparing the time to learn to transform the data between TSNE and UMAP. We have quite difference in terms of time. And then I try to visualize the space with Bouquet. And this is UMAP, and that's TSNE. So without using any specific parameters. So both of them are with default parameters transform. And you can see that I like UMAP a bit better because clearly we have a difference between 0 and, for instance, 3 and 1. So where in TSNE we cannot maybe see that correctly. So I hope you use it, and that's all.
Hi, I'm Mayank. I work at CERN. Be careful. So I work on the Simple Grid project. I gave a talk about it earlier in the day. So it's an open source and community-driven project, so that naturally made us a great candidate for the Google Summer of Code. For those of you who don't know what this is, so it's essentially a program where Google sponsors students from around the world to work on open source projects, and they pay them really well. So we participated under the umbrella organization of CERN HSF. So in the past, I've been a student 2 times, but I think this time I underestimated the administrative efforts involved with the program. So as soon as we opened our applications, there was a flood of candidates from all over the world, and your emails are loaded with like good resumes, great resumes, and ultimate resumes. I had the opportunity to see people who could make Elon Musk quit his job and skyrocket Tesla's stock in a couple of hours. So it's very difficult to deal with that when you're trying to work. So it's important to like step back and think what exactly you're looking for when you're trying to pick the right candidate for the job. A common way to do this is have them work on like certain issues or in your issue trackers. But that kind of focuses the students only on one particular aspect of the project, while over the summer, they'll be working on much more deeper things. So one solution is to leverage like the MOOC platforms, which are massive open online courses offered by Coursera, Udemy, edX, and so many others. And that's something which gave rise to MOOC CA. However, there's a problem with the MOOCs is that a lot of the courses are paid, but the students are not paid. So we still needed a way to figure out their performance in these courses to be able to pick a list of like top 3 candidates with whom we can have like Skype interviews or talk with details. So ultimately we built MOOC CA, which solved the problem. We had a great summer student working with us, and he successfully completed his project. So quick overview of like how everything works. Essentially the students download this Chrome extension called MOOC CA. They then go to our server, which is essentially a Django web app, create an account, they register their Chrome extension as a OAuth 2 client so that it can make submissions on their behalf. Once that's done, they go to these platforms, take the courses that we have asked them to take, and when done, they click the submit button on the extension, and then we have basically a HTML snapshot of their performance. This is like a video of how it works. I don't think we have the time for that. For the evaluators, essentially you log into the Django app as a super user, and then you see a list of students and their submissions, and you can click on it, and basically these are overridden views in the Django admin, where you can take a look at the HTML snapshots submitted by them. It's very easy to use and install. Everything's open source. Here are the links. I'll put the slides on Twitter. And for the server, it's just Docker Compose up, and you're done. Conclusions, MOOC CA essentially takes HTML snapshots through the Chrome extension and sends them to your Django server. Leverages proper MOOC platforms. It's open source and easy to use. So if you're in a situation where I was, feel free to make use of it. Thank you.
Thank you very much. So, you know, I think you heard about PyData. So PyData, where's PyData here? And on this map, you see there's a high density here in Europe. But we discovered there were some PyDatas missing. And this city was not having a PyData. And you probably know which city this is. Huh? Any guesses? Hong Kong? No? No? It's not in Europe, Hong Kong? Okay, so I will reveal soon which city this is. And we also discovered another area which has nice castles and planned cities and industry which has no PyData yet. And next question you will ask is, what about the Germans and the trains? Because this is actually the high-speed at NCN and SNCF website. We're here in Paris. And the first city to reveal it was like, there's a PyData in Frankfurt now. We had 2 meetups, I'm going to tell a little bit more, and 1 PyData Südwest, like Southwest, which is a joint PyData with Mannheim, Karlsruhe, and Heidelberg. And the good thing is, the distances with high-speed trains, because trains are good for the environment, you don't need to fly to go to a conference. Karlsruhe is only like 2.5 hours away. Frankfurt, Mannheim is like 3 hours away, and Frankfurt is only 4 hours away. So of course, I would like to invite you to come to the meetup if you want to contribute a talk. And I will also do my best to contribute speakers from the area back to come to Paris. Like, so I already wrote a message to Uwe, so to come to talk about Arrow. And so yeah, I mean, the message here is about PyData, so in Frankfurt, so we're happy KPMG is hosting it and supporting us. This is some pictures from the first, so you see many happy faces and good content. And yeah, this is the second meetup where Florian spoke, and this is the introduction for NumFocus here, and we had a talk about deep learning, and you see more happy faces. And these were some of the talks we had before, and as I pointed out, it's only like 3 hours and 46 minutes. It's even better than 4 hours to Paris. Okay, and also like PyData Südwest, we are doing this with the Cyber Forum. There's also like Karlsruhe is the German hub for AI, because if you don't know, Karlsruhe has with the KIT an excellent university for engineering and also of IT. And also the University of Heidelberg is a huge hub for research, also especially in the medical field or cancer research. So this was the slide for our last meetup in Karlsruhe, where we had 2 female speakers about data visualization, and as you will see in a minute, about Star Wars and how you can see who's speaking in Star Wars with the neural net. And this was a nice talk about data visualization. And this is Eleni, she's a volunteer, telling everybody about NumFocus and PyData. And the good news is it's only 2 hours and 30 minutes. Basically, you can come by. It's like taking the metro from one place in Paris to the other. So yeah, so keep us in mind. We are on Meetup. Also, we are on Meetup. You can find us on Twitter and Telegram. The hash is @PyDataFFM and @PyDataSW. And if you have any questions, just like ping me or anyone of the team. And yeah, thank you very much.
So Sylvain just stole my opening line, because I was about to say this time we don't need to take the train, but because we are in Paris. But if you need to take the ROR, maybe it will take you more time to go to Germany. So, so I'm Chiara.
And I'm Marina.
And again, Sylvain was saying that there is a problem, we don't have enough female speakers, so we have the solution. So we are the co-founders of the Women in Machine Learning and Data Science meetup. We host events, and everybody is welcome to attend, and also to speak in panels. Sometimes we have panels, but speakers are women. Why? Because we want to have more role models to encourage women to speak, because as you've seen here, we have women speaking in the lightning talks, but Sylvain has to go and pick them up, say, please speak. And in the end, we can speak, we can give good talks. So why don't we have more role models and more examples for women to speak? We have technical talks mainly on machine learning and data science, but Python is everywhere in that, so we have many Python-focused talks too. We have, like at the moment, we have 9 meetups. Next one is soon. We have a meetup group, 1,800 members. We have the biggest chapters in Europe of the Women in Machine Learning and Data Science. It's 30 chapters all over the world. We have a Twitter account with almost 657 followers.
Okay. Okay, so here are our next meetups. So if you want to come and join us, you can check out our meetup page. Also, we have, as Chiara said, a Twitter account that you can just check out there. All our previous meetups and slides are and recaps of what happened are in Medium, so you can just check previous talks. If you are or you know someone that would like to speak, you can just contact us at PyParis at womeninmachineLearningDS.org. And we have a Slack channel where we advertise some events, or even it's a great place also to do a networking. We already put in contact some people to find internships and jobs. And that's also our next meetup. Just to give you an insight, we'll have a first technical talk, industry talk from Capital Fund Management that you already met here. The second talk, it's academic as always, and it will be from a researcher of CNRS. And the last talk this time would be more open, and it's about how to become a tech journalist. And we will have other meetups coming. On January, we will do a joint meetup with the Rexis FR meetup, which is the Recommender Systems meetup in Paris. And the program will be out soon, so hope to see you there.
This is, yeah. I'm gonna do my best, Sylvain. So I'm gonna talk about IPyVolume, interactive 3D visualization for Jupyter, notebook and lab. I'm in lab, as you can see. So my name is Maarten Breddels. You can find me on Twitter, LinkedIn, and IPyVolume is on GitHub, pip, and Conda. So maybe you think, why 3D Viz? Well, of course, we work in a notebook, so it's inline. But what's also important to realize is that if you work with the notebook can be remote, so your data can be remote, but your visualization is local. So it's actually fast. So let me start. So it's really simple to use. If you use Matplotlib or Mayavi, it's quite similar to that. So let me show you. I'm using actually the sidecar widget, so my output is going to be on the right. So just pay attention to the right, and maybe if you want to see the code, watch the cursor. So I'm just making a figure, a scatter, and show it. So this is an interactive widget. You can zoom in and out, etc. And because it's a widget, I can change things from the kernel. So I change the shape to like boxes, or I change an x-coordinate, and it's animated. I can save it to HTML, send it to someone else, or have it on your tablet or phone. And it's built on IPyWidgets. Okay, I don't know what that was. So I can change things from the command line, but I can also create like a toggle button and link this, so I can basically make a small UI to change what kind of marker I'm using. So the same for any attribute. So the size, I can change it to 10. Attach a slider. So the features is basically what you saw: scatter plot, quiver plots for that I'll show later, meshes, lines, and because of the name IPyVolume, it actually shows 3D volumes as well. So maybe you want to show like magnetic fields. If you change them, animate it, you can change the colors. Give each element a different color. Meshes, so you basically define like the coordinates, the vertices, and the indices. So you can have like really simple ones, or more fancy surfaces, like this one. And also this is animated, so you change the color and the coordinates. Nice wireframes. Lines is actually not so easy with WebGL, but they're kind of supported. But it started with volume rendering. So if you have a 3D cube, so here I have a three-dimensional NumPy array, and you can play with the transfer function. And like take a look at what a spherical harmonic looks like in 3 dimension. ISO surfaces. This is computed using SK-image actually. So if I change this, it's actually pretty funny. It does a bit of a weird animation. You can consider it a bug. But performance. So if you have a good graphical card, you can do at least 100,000. You can do 1 million with a high-end graphics card. So they're a bit overlapping. So you change the size, or maybe stretch it out a bit. And it's still pretty interactive. I can't show these. Zoom and pan. So it's really interactive, so I can, because I only have one hand, I can't use the shortcut. But let's say I want to like, zoom into the data or out, or I want to pan it like this. Or maybe I want to make a particular selection, like a lasso selection. And if I change this, this gets executed and does some computation. So it's really interactive. If you have data that is that also has a time dimension, and because of this interpolation, it looks pretty smooth. So this is simulation, and so actually maybe you want to have spheres, but the nice feature are the cats. And if you have a Google Cardboard, you can have it in VR. That's it.
So hi everyone. My name is Alexandre. I'm a data scientist at the French Central Bank. But today I'm gonna talk to you about one of my non-profit pet projects that I'm working on with Alexi, who is sitting over there. So like a lot of projects, this one is born out of frustration. Frustration with the horse race media coverage of politics. And so we wanted to popularize a more statistical and data-driven process. So basically we aggregate opinion polls and we model French elections, and we do that all in Python. So the website that you see here is a pyramid web app, and the interactive plots that you can see here are made with the bokeh library. And here, for example, we collect all the polls, all the approval polls of Macron, and then we weight them according to their sample size, the recency, the sampling method, and the historical accuracy of the pollster. And all that is done with basically pandas, scikit-learn, and well, bokeh. And right now we're working on our European elections forecast, which is going to be a Bayesian model. And we do that with an amazing Python library, which is called PyMC3 for Python Monte Carlo. It's basically you define your models like that as you would do on a piece of paper with your priors, your likelihood, and then you get to visualize your model like that. I mean, how cool is that? This one is fairly simple, but when you get to really multi-dimensional model, it's really useful. And then when you hit on the inference button, you get an MCMC algorithm which does the work for you. And what's really cool with Bayesian modeling is that you get not only point estimates, but you get a whole distribution of your parameters. So you can easily compute the uncertainty underlying in your model. So I really encourage you to take a look at this library. It's really amazing. And well, if you wanna work on your Bayesian modeling skills on a concrete project, or your web dev skills on a pyramid web app, well, get in touch with us. All our contact information are in the website footer, or even better, you can come and talk to us. So thank you. I have a little time. 2 minutes. Great. Great. So I'm just gonna talk about anything else. No. No, just a few words to thank all the PyParis staff for all the work they have done these 2 days. It was really an amazing 2 days, at least for me. So thank you, and happy Bayesian modeling.
And the website is Pulse Position.
Yeah, of course. Yeah, pulseposition.com with a little pun, as you will see here. So thank you, and see you soon, I hope.
I'd like to talk to you about the problem of dirty categories. So I do machine learning and things like scikit-learn, and the first thing we do is, well, your data is a matrix. It lives in R and P. Real life is like that, and it sucks. And what I'm interested really in is that specific column that you see on the side, the employee position title. And the problem is that all those categories, they're not very well defined. They're overlapping. They have a high cardinality, which is, so in this specific data set, we have 400 unique entries per 10,000 rows. There are some very rare categories. We have only one architect 3. And in my test set, there's quite often going to be new categories. That's what we call dirty categories, by the way. So they're actually quite frequent in the wild. So if you look at data set in the wild, often, but not always, the number of categories of those string categories will grow with the number of rows. And it grows sublinearly, but still grows. So our goal with my student, Patricio Ochoa, is to do supervised machine learning on dirty categories without having to clean the data, because everybody hates cleaning the data. It's just like a room. Everybody hates cleaning their room. So the idea is that the statistical question should inform the curation. So, you know, you've got, in the data set, you've got Pfizer Corporation Hong Kong and Pfizer Pharmaceutical Korea. Or should I be treating this as the same entity, yes or no? That probably depends on the task. So there are many related approaches, things like database cleaning, and these are named like, they're canonical names like deduplication, record linkage. This is also related to techniques in natural language processing. So you've got the idea of semantics, of word vectors, and they're related techniques in machine learning. But we have, well, it's not submitted these days, it's published. But so we came up with a very simple idea. The idea is that we're going to do one-hot encoding. So I'll define what one-hot encoding is, but it's a standard technique to map categories to vector spaces. And then we're just going to use string similarities to slightly modify this, okay? So it's really based on string similarities. And so one-hot encoding is maybe the most classic way of representing categories as a matrix is just, you know, you put one where the category is present in a given column and 0 if it's not present. So that's the standard way. It's got many benefits, but the problem is when you've got many categories, it just gives a huge matrix. And what do you do with new categories? So we've just replaced this by replacing the 0 and 1 by a similarity between the strings. It's a very simple idea. Just a string distance. And it works really well. And so just so that you understand these IDs. So yeah, I'm going a bit too fast. So the problem is you get very high dimensions. So you can easily reduce them by using random projections, which is something classic in scikit-learn. So it works really well. And I guess I'm just going to, I mean, this figure is a bit hard to understand, but the point is that this is a number. The higher, the better. String similarities work really well. If you reduce it, they still work really well. And the good news is this is available in software. It's research software, but we think it's very useful and of reasonably good quality. So we call this software Dirty Cat for dirty category, and it's got a cute logo. And this is ongoing research. We'll do better things, but to do better things, we'd like you to give us your dirty data. Thank you.
Hey guys, how are you? Have you heard about edge computing before? Okay. Those who don't know edge computing, do you think it is somehow related to cloud computing? Huh? By any means? All right, so just let me give you a brief about what's edge computing and why the world needs it. So this is, let me remind you also about the tragic accident that took place in the Gulf of Mexico, where on an offshore rig, data leaked from one of the pipes. The cameras on that rig, they were recording, the leaks. More than 13 people, they died after this incident because, a huge explosion took place. More than 3.5 million barrels lost in that occasion. What happened in there, after investigation took place, the black box, they opened it, they found in the tapes that the camera recording were showing the leaks, but it was just, because, as if like any CCTV camera, they just put the videos on the tape without actually processing the, data. Why they can't do it there? Because any typical offshore rigs or any typical factories and so on, like they took place in undeveloped area. It's really difficult to, grab the data from videotapes or from any cameras or any data sources, push them to data centers, and then process the data, wait for it to come back. Usually you don't have this luxury of doing this process. So that's why the edge emerged. So the typical model previously, it used to be, okay, you have a data source where the data is generated. Let it be a camera, a temperature sensor, a pressure sensor, and what have you. You ship the data to the cloud or any data center that you have. You process the data, and then wait for the results to come back for you to take actions. This is simply high cost, latency, associated with it because you're shipping data all the way, right? So for that purpose, they're established a layer between cloud and ground. It's called fog, and basically this is where most of the edge computing and fog is happening. The hardware devices itself is getting more complex in terms of computational resources. The software also is getting more advanced in terms of running on low footprint devices. That's why we see this trend coming in opposing the cloud computing. So we see more like IoT devices getting smart, doing machine learning algorithms and so. So I work in a company called Foghorn. We established in the Silicon Valley on the mission to provide software to IoT devices to handle this. And part of that, we also provide something called edgified machine learning, where you have you can import Python codes into low footprint devices such as it could be a Raspberry Pi or any PLC, existing PLC, DCSs, and what have you. So that was it. Thank you all.
So this is the last sequence of our conference. I hope that you're enjoying it so far. Sorry, it's not the right screen. You're not supposed to show you're not supposed to see my stuff. So first of all, I want to thank you, all of you, the more than 300 participants to this conference. Actually, there were more than 300 registered participants just to PyParis, and almost 50 more participants to the education tracks we had yesterday. We had 50 speakers, 11 sponsors, and the event was set up by Florence Blasi and the whole team of from Systematic Paris Région, who did a very great job, in my opinion. A few statistics about who attended the conference. It's not from, it's just from, sorry. There are some data missing, so just from a sample of the 300 plus participants, obviously most of you come from France, but there are also strong delegations from Germany, Spain, UK, Belgium, and other countries. If your country is not in this list, it's probably because you're a speaker, because the speakers were processed differently. I want to thank again the program committee, 11 members. We worked on all the proposals. We got about, I think, 100 proposals. All of them, except maybe one, were quite good, actually. So my feeling is if we had just taken the bottom 50 proposal, bottom in terms of, let's say, a very personal opinion, we could have done something almost as great as the conference we actually had. Let me thank again the sponsors, so Systématique Paris Région, the cluster, pôle de compétitivité, comme on dit en français. So with 800 members in the Paris region and with a strong open source and logiciel libre focus. EPITA, well-known, famous engineering school for computer science. You've seen the beautiful venue. This place is quite new. I think it was finished this year or last year. Then we have the platinum sponsor, Microsoft. Thank you, Microsoft. The representatives from Microsoft had to go on a plane somewhere else. So they won't give you the pitch for their product, but I guess everyone knows Microsoft and what they are doing and knows that they've changed quite a bit in the recent years. Why First is another sponsor. They will give you a very short presentation in a couple of minutes. Rapid Space from Nexedi, you got the presentation yesterday. Abilion, my company, DoLead, JetBrains, Logilab, Saint-Gobain, and Stat4 Decision. What are the next steps? All the speakers, please send me your PDF, your presentation, if you've not done already. As soon as I get them, I will put them on the website, so except to see the first document showing up tomorrow. And also regarding the videos, I've been told by the production company that the video will be done quite quicker than in the previous years. And we should see the videos show up on YouTube next week, hopefully. Let's meet again. Yes, next year there will be probably a PyParis, and it will be probably in June, like we did before. We had to do it in November this year because of practical reasons. We don't know yet in which venue. We've got EuroPython. Our German friends are already gone. Yeah, maybe they are two. Oh, you're here. So is there any news on the location?
Like 3 cities left, and the final decision will be in like by the end of the month.
Okay, so
all the days will be in July.
Okay, so final decision in a week, and yes, in July as always. PyCon FR, next edition will be in Montpellier this year. They don't know yet the exact date, but it will be probably, I guess, in September or maybe October, I don't know. We've got the PyData Paris and other Python-oriented. Hello? Yes. Sylvain Corlet, Sylvain still here, yes. Eric Le Bigot, where are you? Where are you? I don't see you. No. Sébastien, Emmanuel, where is Emmanuel? Emmanuel, yes. So we are the organizers of this meetup, and we have one meetup per month or every 2 months on average. And of course, all the great Python events that were presented, especially for the German ones. So there are plenty of opportunities to speak and to meet other Python developers, and it's quite great. So for next year, from what I've heard in our conversation, you are quite happy, and I am quite happy with how the event turned out this year. So, but we can still try to improve the event for next year. So there will be a poll that will be sent to all the participants in the mailing list, and please answer the poll and tell us how we can try to be better. So thank you.